So for our last lesson, believe it or not, we are basically going to be looking at projectile motion again, but we're going to be doing some problems that you wouldn't have been able to do by hand or just by using factoring. So Desmos is going to be your best friend here again. And it's really just important that you know, one, how to type things into Desmos, and then two, just how to interpret what Desmos is telling you. Because obviously Desmos can't give you the answers if you don't know what you're looking for. So we're going to do a couple of these practice problems. We're not going to do all of them, but it's going to be important that we have a good handle on kind of how this navigates. So here we're going to jump in. Greg is diving off a diving board, right? Similar to our similar problems. We've got our equation right here, x squared, negative x squared, plus 3x plus 3. And the question is, well, what's the maximum height, the maximum height that Greg's going to get to? Well, we could try and use our hand methods. We could use our, factoring or quadratic formula. But the truth is that we can simply just visualize this using Desmos. So negative x squared, we're typing it in, plus 3x plus 3, right? So I'm going to click my home button here so I can kind of zoom back in. And you can see, here's Greg jumping off the diving board, right? He achieves his maximum height, and then he comes all the way back down, and that's actually where he hits the water. So you actually just found your answer. What we cared about was what was the maximum height, right? And and how far away from the diving board is he when he enters the water? So there's actually two questions there. The first is, what was the maximum height that Greg achieved? So if you look back at our Desmos screen, our maximum height, don't be fooled, is not 1.5. The 1.5 is actually the distance away from the diving board when he dove. Okay, so the 1.5 is not his maximum height. Your y value, 5.25, that's our maximum height. So I'm going to type that in here because it's easier to type on this than to write. But our maximum height is going to be that 5.25. That's our maximum height. So max height at 5.25 feet, right? So there we go. That's our maximum height. Now the second question was, how far away from the board is he when he enters the water? So that's this last piece here. He's flying through the air and he hits the water right here. So how far away from the board is he? He's about 3.8 if we round. He's 3.8 meters away. So, actually, this was wrong. This should have been meters. I just assumed it was feet, but then he's 3.8 meters away from the board. Okay, so we're using Desmos 100% here. I didn't do any math myself. It's all Desmos related. But again, Desmos is not a magic wand. If you don't know how to interpret what Desmos is telling you, you're still screwed. You've got to make sure you know what Desmos is actually saying. Okay, so we're going to try another. And again, we're not going to do all of these, but we're going to do some. This is one where we've got three different components about a rocket flying through the sky, right? And I like this one because there's a couple different components to it. So I'm going to get Desmos back out. Wrong thing. Get Desmos back out here. And you'll notice that your equation is written maybe in a different way. Totally fine. We can still write it. If you want to use x, you can still do that t as well. But I believe t is going to work here. So let's see. H equals 1440 t minus 16t squared. And you might be thinking, Crouch, that's just a straight line. It's not just a straight line because, again, like we talked about in our last lesson, there is more parabola here. We just can't see it, right? And even if I zoom out and drag a whole bunch, now we start to see what's going on. But I still don't love this. I still don't like it because if I just click zooming out, it's going to get really skinny. I still can't see the top, right? Okay, now I can finally see the top there, right? But this doesn't even look like a parabola anymore. So I'm going to teach you what you can do to kind of see, oh, okay, this is not this is still a parabola. So what you'll notice is that, okay, how high did we really go? It's about 32,000 something feet, right? So instead, going way back to the home, what I'm going to do is I'm going to click on the wrench, and I'm going to change how high and low my X and Y can go. So I'm going to change my X, my Y, all the way up to, let's just say, 40,000, okay? And you'll see as soon as I do that, that my parabola starts to take shape. But I've got to change my Y as my X as well. Now, I didn't look at what that was, but let's just estimate. Let's just go with 100. There you go. We've got a 100. We've got a perfect parabola now that you can click on and drag a little bit easier. Now you can visualize what this really looks like, right? So if you get that crazy straight line, you can't even see what the parabola looks like. Click on the wrench, change your numbers here just a little bit so that you can kind of get an idea of what the parabola actually looks like. Now let's go back to the question. It says, after how many seconds will the rocket reach 25,000 feet? Well, if we're trying to figure out when it reaches 25,000 feet, I've got really good news for you. This used to be super tough. It's actually super easy now. All we have to do is say, hey, when will H be 25,000 feet? We just type it in, right? And I gotta take that back because it's not doing it. That's interesting. What I'm gonna have to do here is instead, I'm gonna have to type Y in order to get that horizontal line. Okay, so Y and H, remember, are interchangeable. So we're gonna type Y instead. And what that does is it creates that vertical line, that horizontal line straight across. And these are the two times when our parabola gets to 25,000 feet, or a rocket in this case. So there's actually two answers to this question, right? After how many seconds will the rocket reach 25,000 feet? Well, the first time is on its way up at 23 seconds and 23.5 seconds. So that's our first answer. Gotta get a little smaller there to make it fit. 23.5 seconds. 23.5 seconds, right? That was on the way up, and went on the way down. 66.5 seconds on the way back down. 66.5 seconds on its way back down to Earth, right? So visually, that's so much easier now that we have Desmos to visualize that actual scenario, okay? Question number 2 says, well, what about 35,000 feet, right? When will it get to 35,000 feet? So if I change this to 35, not 55, like, well, it's not there, Mr. Crouch. Where is it? Where is it? Let's zoom out a little bit. Oh, it's right there. So what does this mean? It means that it never gets to 35,000 feet, right? It actually only gets up to 32,400. So it doesn't reach, right? It never reaches 35,000 feet. Okay? Pretty cool. Last thing is, when will the rocket hit the ground? When will our rocket actually come back down from outer space or wherever it is and hit the ground? Well, remember, this is where it took off. It's flying. It reaches its maximum height at 32,400, and then it comes back down and hits the ground right there. So when are we hitting the ground? 90 seconds after liftoff, right? We're going to hit the ground 90 seconds after liftoff. And there we are. So I'm hoping you're seeing how Desmos, if you know what you're doing, answers your questions with a lot of ease. It really helps us to visually understand what's going on and then be able to answer those questions relatively easily. Okay? So I'm going to move forward to a couple more in the next video, but do the rest of these if you need to, if you want some more practice.